Okay, so in this video I want to talk about Fourier series of functions of any period. So previously we've been talking about Fourier series of functions with period 2 pi, okay? And for functions that are 2 pi periodic, we saw that the Fourier series is given by the following form here, okay? And where a0 is the is given by 1 over pi, the integral from negative pi to pi, f of x dx, okay? And a of n is 1 over pi, the integral from negative pi to pi, f of x cosine of nx dx, and the coefficient b sub n is 1 over n, the 1 over pi, the integral from negative pi to pi, f of x sine of nx dx. Okay, so this is for functions that are 2 pi periodic. All right, so what we want to do now is look at a Fourier series of functions of any period. All right, so in this case we're going to let f of t be a periodic function with period 2l, okay, where l is just some number. Okay, and we can, in this case, we can actually change the interval from x to t such that when x changes by 2 pi, all right, t changes by 2l. So t is actually some function, linear function of x, okay? So if we can determine what this alpha factor is, then we can determine the relationship between t and x. Okay, so how do we determine that? Well, if t changes by 2l, okay, and the x changes by 2 pi, okay, then this alpha has to be L divided by pi. Okay, so this would imply then that t has to be L over pi x. Okay, and using this change of variables, we can find the Fourier series associated with any periodic function. Okay, so in this case then, let me take another sheet of paper. So in this case, then t is equal to, as we said, that is L over pi x. Okay, so that is L over pi x. And so in this case, then we just need to change the variable. So in this case, if we solve for x, well, x is just going to be pi over L t. Okay, so in this case, my Fourier series, which is going to now become, okay, so this is the Fourier series. So in this case, this will just become f of t, which is equal to a0 divided by 2 plus the summation from n equals to 1 to infinity a sub n, okay, cosine of nx, but x is now pi L over t, so this is going to be n pi over L t, okay, plus b sub n sine of n pi over L t. Okay, where I've just substituted for x this expression and pi over L t. Okay, so this is the Fourier series for a function that has a period of 2l. Okay, now similarly we can transform the coefficients a0. Okay, so in this case now a0 A0, okay, this is the function of x. So we need to write this as a function of t. So we need to somehow calculate this dx. So from here, we can show that dx over dt, okay, well, that's just pi over L. All right. And from here, we can show that dx is just equal to pi over L dt. Okay? So that is what dx is. And similarly, we can change these limits. Okay? So when x equals to negative pi, okay, t is equal to, well, t is given by L over pi times x. So when x is negative pi, then negative pi divided by pi, that's negative 1. So in this case, we will just get negative L. And when x is equal to pi, okay, t will just be, once again, when x is pi, then pi divided by pi is 1, and that will just leave us with L. Okay? So now we can write this coefficient as, well, dx is pi over L, so we can take that outside, and the pi here will cancel out with the pi here. Okay, so this will leave us with 1 over L, integral from negative pi to pi, but this time this is going to be from negative L to L, f of t dt. Okay, where for dx here, I've just substituted this expression. All right. So this is the coefficient A0. And similarly, we can transform for the coefficients an. So in this case, an is going to be given by, once again, dx is just given by this expression. So this will leave us once again with 1 over L, integral from negative L to L, f of t, cosine of nx. So that's going to be n pi over L t dt. Okay, so that is the coefficient a sub n. And finally, the coefficient b sub n similarly will be 1 over L, integral from negative L to L, f of t, sine of n pi over L t dt. Okay? So this now gives us our Fourier series. So this is our Fourier series of a function that is 2L periodic. Okay? So this is the coefficient A0 associated with that, A1, AN, I'm sorry, AN, and this is BN. Okay, so that is our transformed Fourier series and Fourier coefficients.